am Teacher Darji, and I would like to share to you the learning activity sheet in Mathematics 7, Quarter 3, Week 1, Lesson 2. Segments and their measures. The three undefined terms in plane geometry are point, line, and plane. Relationships between these objects are defined and described in the activities that follow. First, collinear points. These points lie on the same line. Next, coplanar points or lines are points or lines that lie on the same plane. The following activity sheet will help us develop the definitions of the other relationships. Given the points A, B, C, D, E, F, G, H are corners of a box as shown, let us identify some geometric terms on lines. First, intersecting lines. Lines DH and DC intersects at D. Lines CG and GF intersects at G. Next, parallel lines. Lines AB is parallel with DC. Lines DH is parallel with CG. Next, concurrent lines. Lines AD, AE, AB are concurrent at point A. Lines GH, GC, and GF are concurrent at point G. Next, skew lines. Lines DH and EF are neither parallel nor intersecting. These two lines do not lie on the same plane. Another example, lines AE and FG. They do not lie on the same plane, neither parallel nor intersecting. Now let's have a recap on these four terms on lines. Two lines are intersecting if they have a common point. Three or more lines are concurrent if they all intersect at only one point. And parallel lines are lines which do not meet, and skew lines are lines that do not lie on the same plane. Next, let's proceed to subsets of lines. The line segment and the ray are some of the subsets of a line. A segment has two endpoints, while a ray has only one endpoint, and it is extended endlessly in one direction. Let's have first the line segment. Line segment AD has 4 points, A, B, C, D. In notation, we write AD with a symbol or without symbol. This is considered or this is understood as segment. We can also name it as line segment DA or simply DA. Next, segment FH. FH has 3 points, points F, G, and H, while points E, I, J are not on the segment FH. Next, we have this line segment AV. Okay, so there are a lot of points between AV. Let's focus on segment EQ. EQ. There are points like E, F, G, and J that lie on segment EQ, while C, D, V, U are not on line segment EQ. So what is a line segment? A line segment is a part of a line that has two endpoints. We define a line segment AB as a subset of line AB consisting of the points A and B and all the points between them. If the line to which a line segment belongs is given a scale so that it turns into the real line, then the length of the segment can be determined by getting the distance between its endpoints. For example, this line segment AG. Line segment AG has scales from 1 to 11. So to know the lengths, we simply get its distance. There are two ways. For example, what is the length of line segment AD. So we can do skip counting. Start 1, 2, 3, 4, 5, or by subtracting its coordinates. 6 minus 1, that is equivalent to 5. Or let's say BF. What is the length of segment BF? So skip counting 1, 2, 3, 4, 5, 6, 7, or simply subtract 3 from 10. So 10 minus 3 is equals to 7. From these line segments, let us identify some congruent segments. So segments are congruent if they have the same length. So for example, AB has 2 units. Same with EG. So AB, EG are congruent. Another, we have line segments BD and DE. Since BD has 3 units, same with DE. So that is learning task number 1. Next, let's proceed to ray. So we have here ray AC. We can also name this as ray AB. So in symbol, we write AC with a symbol above it. Okay, another. This ray is pointing to the left. So we name this as ray ZY or ZX. So if you notice, we name rays beginning its end points. We cannot name this as ray XY, not also as ray XZ. Next, ray DE. You can also name it as ray DF, ray DG, and the points D, E, F, G are on ray DE. Another is ray TS. So we begin with its endpoint, TS. So we can also name it as ray TS, ray TR, ray TQ. Points QR, ST are on ray TS. Next, we have ray ML. So M is its endpoint. You can also name this as ray MK, MJ, ray MH. Next we have ray QR. The points Q, R, S, T, U are on ray QR. The points N, O, P are not on ray QR. What is ray then? A ray is also a part of a line, but has only one endpoint and extends endlessly in one direction. We name a ray by its endpoint and one of its points. We always start on the endpoint. We have here ray AB. So we can also name it as ray AC, but it is not correct to name this as BA or CA. Let's proceed to set operations involving line and its subsets. So since the line segments and rays are all sets of points, we can perform set operation on these sets. We have the union or intersection of segments and rays. Use the figure below to determine the part of the line being described by the union or intersection of two segments, rays or segment and ray. Example, DE, ray DE, union CF. So we begin with point D. Ray DE, union with CF. So the endpoint of DE is D and the endpoint of CF is at C. So it is the set of all points on the ray DE and segment CF. Thus, all these points determine ray CD. Ray CD, ray CE, or ray CF. So we will begin with point C as its endpoint. Next, ray BC, intersection ray ED. So BC begins with B, going to the right. Ray ED starts with E, going to the left. So when you say intersection, it is the common points. So first, we start from C, going to the right. And the next, we begin with E, going to the left. So it is the set of all points common to ray BC and ray ED. Then the common points are the points on the segment BE. Since ray BC has points on segment BE and ray ED has points on the segment EB. So their intersection is segment BE. So your answer in learning task number 3 are segments, ray, or line.